Large language models, or LLMs, are the technology behind ChatGPT, Claude, and Gemini. Let's break the name down. Large means billions of internal settings, called parameters, trained on trillions of words. Language means it works with text, reading, understanding, and writing. And model means a mathematical system that captures patterns. The simplest way to picture it is autocomplete on steroids. Your phone predicts the next word in a text message. An LLM does the same thing, but so well that it can write entire essays, answer complex questions, translate languages, write code, and hold extended conversations. That's the core idea. Everything else in this lesson builds on it. It's just a system that predicts language, one word at a time, at an enormous scale. So what makes modern LLMs special, scale? Back in the 2010s, language models had millions of parameters, were trained on gigabytes of data, and cost thousands of dollars to build. They could do basic prediction. Modern LLMs from the 2020s have hundreds of billions of parameters, are trained on terabytes of text, trillions of words, and cost millions of dollars to train. And they can do complex reasoning. Here's the breakthrough that surprised researchers. With enough scale, new capabilities emerge, abilities that smaller models simply don't have. Nobody programmed them in directly. They appeared once the models got big enough. That jump from basic prediction to genuine reasoning is the reason LLMs suddenly captured the world's attention. Building a useful LLM is a pipeline, and each stage moves the raw model closer to the assistant you actually talk to. First, data. Teams gather enormous text collections, websites, millions of books, academic papers, code, conversations, and news, then clean it up. Second, pre-training. The model learns to predict what comes next. Given the cat sat on the, it learns that mat is likely and elephant is not. Over billions of examples, that builds a rich understanding of language. Third, fine-tuning. A raw model isn't very useful for chat, so it's taught to follow instructions, hold back-and-forth conversations, and avoid harmful content. Fourth comes RLHF, which we'll cover next. Finally, deploy, serving the finished model to users. Let's zoom in on that fourth step, because it's what makes an LLM genuinely helpful. It's called reinforcement learning from human feedback, or RLHF. Here's how it works. Human reviewers look at the model's outputs and rate them. The model then learns from those ratings to produce the kinds of responses people actually prefer, responses that are more helpful, more accurate, more appropriate, and less harmful. Think of it as coaching. Pre-training taught the model language, fine-tuning taught it to follow directions, and RLHF tunes its judgment based on real human preferences. This step is crucial. It's a big part of why today's assistants feel useful and safe, instead of just spitting out raw, unfiltered text predictions. Every modern LLM is built on one architecture, the transformer, introduced in a 2017 paper titled "Attention is All You Need." The key innovation is attention. Older models read text one word at a time, in order. Transformers can look at all the words at once and figure out which ones matter most for understanding each word. Take the sentence, "The cat sat on the mat because it was tired." What does it refer to? Attention helps the model see that it means the cat, not the mat. That's why Transformers won. They process all words at once, they're highly parallelizable so they train fast, they handle long text better, and they capture rich context. GPT, Claude, Gemini, Llama, all Transformers. Let's meet the main players. GPT, short for Generative Pre-trained Transformer, is from OpenAI and powers ChatGPT, with each generation growing more capable. Claude comes from Anthropic, founded by former OpenAI researchers, and is known for longer context, thoughtful responses, and a safety focus. Currently, the Claude 4 family, Opus, Sonnet, and Haiku. Gemini is from Google DeepMind, notable for being multimodal, handling text, images, and video, and for tight integration with Google's services. Llama comes from Meta and stands out for being open source, which enabled countless research projects and smaller companies. And there are others worth knowing: Mistral from France with strong open models, Command from Cohere for enterprise, and Grok from Elon Musk's xAI. LLMs are genuinely impressive. They handle language tasks like writing, summarizing, translating, and answering questions. They tackle reasoning, solving math, debugging code, and analysis. And they're creative, brainstorming, drafting, and role-playing. But understanding the limits is just as important. They only know what was in their training data, so they can miss recent news and hold outdated information. They don't truly understand. They predict text patterns, so they can describe physics without knowing what falling feels like. They hallucinate, confidently generating false facts, invented citations, and plausible-sounding nonsense. And they sometimes lack common sense, missing obvious things a human would catch, including when a question is built on a flawed assumption. Powerful, yes, but never something to trust blindly. One last concept: the context window. That's how much text an LLM can process at once. Early models held only a few thousand words. Today's leading models handle hundreds of thousands, and the newest reach around 1 million words, enough to take in entire books in a single request, and it's still growing fast. A bigger window means longer documents, more detailed conversations, and better grasp of your full request. So, to recap, LLMs predict and generate text at massive scale, built on the transformer's attention mechanism, refined through pre-training, fine-tuning, and RLHF. And they're powerful, but capable of hallucinating. Want to feel this yourself? Head to the lesson page on FreeAcademy.ai and use the interactive playground, or ask ChatGPT or Claude a question and watch it predict right now.